In this video, we learn how to see the ASIC design flow in cadence. Cadence recorder, that is physical design. Okay, what are these basic steps you have to follow in this? This is the part 2 of my already in one this I have shown the steps. Same thing here in little bit more detail. Okay, so first in the design flow, you have to take these two library files, that is tech.lib and tech.left. So that this you need to import into the design. Okay, with your Verilog netlist file. Okay, model. So this all you have to import into the design. So that is the first step. You have written the code, you have compiled everything, you have done that netlist file you have to call, and this also you do. This is called the physical design. Okay, so in that you have to import the design. After importing, then you have to do floor planning. Okay, where to place the circuits. Then you have to do power routing. Power means supply, VDD, VCC. Then how to place the cell, that is your code, how should be placed. Then you have to connect all the clock trees, how you have to synthesize. Then you have to do the signal routing, how it is done. Then you do the verification, and lastly you do the GCD file, which is used for fab. Okay, so this same thing is explained in detail here. So first step is import the design. Okay, that is the gate level netlist, then the leg files. Okay, power and ground net definitions which are there. Create a MMC configuration file. Okay, save the whole imported design as file name dot globals. Okay, give some name and save this design. That's the first step. So the GUI look like this. This is the MMC browser. Okay, it will look analyze view setups, post analysis views. So this is your window. The whole design import window look like this. So this is the import your file, Verilog file, that is the netlist file. Then their technology files, left files, .lef, where it is there you select those. Then any power VD, okay, you have to select VD VSS. Any analysis configuration view definition we kept default if you want. So click OK. So these are the first settings. This is the first step in the physical design, that is importing your file. Second one, same floor plan. Floor plan of a design is the first step after the import of the technology files and gate level Verilog netlist. In this, the floor plan is to be prepared for power supply, placement of I/O pads, RAM, hard macros, and standard cells. Okay. That is, the designer is required to determine the die size by arrangements of the IOs and the pad frame to core distance. That also. Moreover, the core rows needs to be interrupted where the hardcore should be attached. So this is the so this is your die size, and this second one is, so this settings you have to design in this. Okay, in the floor planning. Then power plan, the task where the power supplies of the core rows and macros are specified is referred to as power planning. So the designer needs to design the power rails around the core and block by choosing metal layers as physical locations and width of the supply. So this PDD, VSS, relay, and these connections between these two. because these two should be connected. Then cell placement. In this task, the information that is the gate list is placed in the standard cells on the floor plan. The standard cells may be arranged by providing the timing information generated in RTL sensors. Okay. Now your code, that is the gate level netlist of your code, is placed for your circuit. So this, it look like this. So see here, earlier you connected VDD ground. So this is your cells, how they are placed inside the main core. So this is your core. This is your model. Okay, how this is connected, you see. VDD, VSS, all are connected. Then clock tree. After placing the location of the register. After placement, the location of a register is known as a clock tree can be synthesized. The constraints frequencies are obtained from the clock tree specifications.cts file. Then the clock buffers will be placed in the gaps of the floor plan. Further, due to the nature of CTS, the clock tree will be routed in this step ahead of any other signal. This guarantees the clock tree will be routed in the most effective way, and therefore by clock skew will be reduced. Okay, clocks all will be connected where buffers need to be added. This is done automatically by the tool. Then power routing. The power supply specified during power plan needs to be connected to in this task. SOC encoder will create connections between the core rows and core rings, and from the core rows to the core supply pads. Okay, so pads may be in the outer, so that all connections it will be done in this. Then signal routing. In this task, the signals as specified in the netlist need to be routed to complete physical placements. Okay, so the tool will try to optimize any routing. Okay, anywhere you have to optimize, it will optimize. Then verification. This is the final step by the design. Six, everything is connected and fixed, and no other errors. Checking all the violations, anything is in it. Then lastly, you should export the GDS. This is export. In this step, the layout needs to be exported in GCD format for further analysis with the cadence purchase. So we will, from this generator, you will generate the GDS file, okay, which is will go to the fab, and your IC will be designed. Okay, so these are the basic steps in cadence and counter physical design ASIC. Okay, so that's all in this video. Thank you. Please like, share, subscribe to my channel. Thank you for watching. Please subscribe to my channel. Thank you. Thank you. Thank you.